Hello everyone. It's come to my attention, and I just actually kind of realized that I've always said to go to the help files and look at them and read them as a way of learning some of these events. And I realized some of the help files can be a little esoteric and convoluted to read, and sometimes it's hard to glean out the information from there. You get better at it as you do it more often, but I figured I'd do a quick video as to how to read an M file or MATLAB help file to get the most out of it. And so this is just a quick example of how I would approach it as a way for you to learn from MATLAB what the functions are telling you to do. So to start out with, I'm going to do the help function for max, mainly max because we just used it. Actually, no, I'll do sum. That would be a good one example. We'll start with that, and I can give one other example to read. So we'll start out with, thankfully, MATLAB kind of has a general form that it's going to take. It's usually going to show the function. It's going to show the output of that function, and equals to the assignment operator, the equal sign, and then the function itself. And then here, like the inputs that go into that function. Here, sum is just a single value x in this first example. And each time it will repeat throughout here, if alternatives exist, it'll repeat itself over and over again how it is used to run. So the first one, the most common function that it's telling you is sum of x, where x is simply a vector x. And it's telling you, okay, so if it's a single vector, a single row or a single column of data, it's just going to sum it. That's all it's going to do. If it's a matrix, meaning if it's a n by 2, for example, or a 2D matrix, you have a length and a width there. It's going to sum the rows up over each column. So every column is going to get a sum. So we know that, and that's kind of straightforward. But then you can look at the next feature, and this is probably what was helpful for the last last homework problem. You have the sum, and it then says sum x comma dim, and now it's telling you that it can sum along the dimension dim. And here, while it's weird that it's saying now dimension, we don't actually know of anything to say a dimension, but the dimension is just the order of the function that's being summed for. So for example, in this way, if we created an array that was equal to, I'm going to create a random number, and it's let's create a 5 by 5 matrix, a 5 by 5 number. If I wanted to sum this up down in the rows, then I would just say sum of A, and that'll give me the sum along this direction. However, if I wanted to go ahead and sum up along the columns, along each, rather than sum the columns, but rather sum the rows in this direction, I could say sum of A comma 2, the second dimension, in other words the row dimension, is equal. You can see that. Now, why do they say dimension instead of just saying sum along rows, sum along columns? Well, it's because of one little thing that I really haven't talked too much about, but I can show you now really quickly that the array data in MATLAB can actually take more than just 2 dimensions. It doesn't have to be just rows and columns. It could actually have a depth to it, so to speak, a 3D array. It could be a 4D array. The arrays can take multi-dimensions. So for example, if I wanted to create A as a random, or in rand, a 5 by 5 by 5 array, you'll notice now it's going to be 5 separate networks, or 5 separate arrays visually stacked on top of each other. This is actually not, you can't see it this way because they're showing here it's all the length and width, or the rows and columns, for the 5th dimension, for the 4th part, for the 3rd stack, for the 2nd stack, for the 1st stack. So if I wanted to use the sum command along the 3rd dimension, effectively across the depth, then I would put a 3 here, and that'll give me the summation of things kind of coming into and out of the board along this position here. So that's why I used dimension as the description there, and why you can do that. Now you can go further down and you can say sum type, so it specifies the type in which the sum is performed, and the available answer here. This is just the typing here. They're giving you examples of type tick and sum. Double is a classic double for any array, so this just changes if you're going to have a floating point number, a double number, and an integer. If your values are, if you have different kinds of mathematical constructs, you can change it here. And then here it says sum missing. It tells you how to include it, and if you want to, if you have missing data or NaN or something along those lines, how to deal with those, and so forth. So there's a lot of information here that can be useful for you, and learn how to use that. Give you another example. If I was to go to help, and let's think of I'm trying to think of an example where you may not have used or played with a lot of, but I will just go with max, because I think max is a good counter example of something else we've run into. But here, it's saying, obviously, let's do help on length. Maybe length will be interesting. Length. Nope, that's not interesting. It just gives me that. Let's see here. Help max. We'll just go back to max. Okay. So max is good. Obviously, we said already it gives you the vectors of max, x, the largest element, matrices, and so forth. If you don't say anything other than that. Now here it's giving you examples of how the outputs are going to be. It's important whenever you read these files, look for the first instance in how it's calling a function, effectively how it's going to define a variable. Look for the equal sign, look for something in front of it, and then after it. This will give you a sense of exactly how is it going to be assigning variables. By knowing this, I instantly see, by looking at this help file, that max can output two separate vectors, or two separate variables, I should say. And then it tells me, well, max will output the largest component, given as y, but here it's now telling me I can also get the I, which is the index of those large points. We already talked about this in class, but it's kind of an important view on how this is going to be seen. However, we're not limited to that. If you remember now, going back to what we saw with sum, we have another option too for our max value. We have our y, I, and then we can also, well, if we say x comma y, it returns the array of the same size as x and y with the largest elements taken from x or y. Either one can be scalar. So this actually allows you to return the largest value of a couple different arrays in those matched systems. If you want to actually change the dimension in which it's going to find the max value for, so for example, if I have a is equal to 1, 2, 3, 4, 5, and 6. Oops, and I gotta go back and fix that a little bit. Here we go. Come here. Okay, there we go. So we have a as a column, as a vector. If I say max of a, it's going to give me the value of 4, 5, and 6. Why? Because it's finding along the columns, much like sum, only sums along the columns, of 4, 5, and 6. But you'll notice here, it's telling me a new format. If I type in x, comma, an empty array, and then a dimension, like we did with sum, it can actually change the way it's going to define the max. So in this case here, if I do max a, give an empty input command, and then say 2, like we do with sum, it should find along the rows here what the max value is. And sure enough, 3, 6, it does that. I'm curious to know, because I have never really played with the max function where it inputs two different arrays. So why don't we test that to see how that works out if we have x comma y? So we have an a. I'm going to create a b vector where it is, say, 3, 3, 3, 3, 3, 3. I'm just going to create all threes. So if I said max of a comma b, I can start to see, oh, okay, I now see what's happening. It's comparing the two vectors, or the two arrays, a and b, and it's giving me the number in the associated positions. That's the maximum value between those two arrays. So obviously, if I'm looking at, let me just put A and B in so you can compare it all top. This is the maximum value. This is the value for A and value for B. So it's comparing these two positions, and it says 1 and 3. Well, 3 is bigger, so we're returning that. 2 and 3. Well, 3 is bigger, so we're going to return that. 3 and 3. 3 are the same, so it's just going to return that. And then 4, 5, and 6 is largest, so it's along the bottom here. 4 is bigger than 3, 3 and 3, so we have that. That's exactly how that's working, and that makes a lot of sense once you play with it, and once you see how that kind of plays a role. And you even go further. You can actually say it gives you information as when it is complex, what you can do. My take-home message is how you do this is you don't sit and read it all at once. Read it in chunks and see if that makes sense to you. And then go to the next chunk and see if that makes sense to you. And then once you know enough to do the problem that you want to do, to get the information out of it, then you can skip that and you don't need to read further. But importantly, it does take a little bit of parsing. It does take a little bit of time to sort through how these help files are read and how they can be interpreted. Let me see if I can give one more example. Sphere. Let's see the help function on sphere. Here it generates a sphere, x, y, and z. Okay, that's interesting. It generates a sphere. So sphere of n generates a 3n plus 1 by n plus 1 matrices so that surf x, y, and z produces a unit sphere. Oh, interesting. Okay, so x, y, c is sphere uses an n is equal to 20. Okay, so let's see what this means. First and foremost, I can see right away in this function, it's telling me that it's going to output 3 separate vectors in x, 3 separate values in x, y, and z. So why don't we do that? So I'm going to say x, y, and z is equal to sphere. It says the sphere gives me 20. I'm going to be simplistic and say 30. Well, let's say 10. The numbers will display better. Hit enter, and what do we get? Oh, okay, like it said, it's let's see, help on sphere again. It's a n plus 1 by n plus 1. Yep, I said 10, so it gives me 11 positions of an x, y, and z array. And it said it's use this so that if we use surface, we should plot a sphere. So if we say surface, and I say x, y, and z, it should create a sphere. That doesn't look much like a sphere. Let's see if I can rotate it. Oh, there you go. That looks more spherish. So yeah, sure enough, it created a surface plot for data, so it created a sphere. Now that I see that, I bet we can make that a little bit cooler, because we can go back to our x, y, and z. Remember, we just learned that we could call x, y, and z by reading the help file and saw that it did that. I bet if we made a 50 position sphere, it'll be less jaggy than this, because there'll be more data points to define that. So I'm going to suppress this, and I'm going to plot surface, go back, and sure enough, it is a nice, more sphere-y sphere. Good for the sphere. So that's exactly how that works, and that's all there really is to this reading the help files. But like I said, it's going to require some practice and some time, but by just simply taking the time out and doing this, you can learn a lot more from this. What this means, though, is it does take some time. So starting homework in a reasonable time frame is critical to actually being able to get things done and finished soon enough. So hopefully that made sense, and I'll try to do more of these videos as they come up. If there's something you want explained better, or you think that there's some feature that maybe you're missing or that I didn't explain clearly that would be helpful in the video, please suggest it. I'm more than happy to make these as useful as possible to you. So anyways, have a good evening.